Good afternoon, everyone. Welcome back to the Vikram Sarabhai Memorial Lecture. I would like Dr. Prakash Chauhan to brief about the introduction.
Good afternoon to you all, and good afternoon and welcome to Shri S. Somanath ji, Secretary, Department of Space and Chairman, Indian Space Research Organization, for the deliberation of the 32nd Vikram Sarabhai Memorial Lecture, which is conducted by Indian Society of Remote Sensing. First and foremost, I would like to thank Shri S. Somanath ji, the national hero. Many of you must have seen him during the entire Chandrayaan-3 journey and subsequently. Thank you very much, sir, for joining today on this occasion when we are inaugurating this national symposium conducted by Indian Society of Geomatics and Indian Society of Remote Sensing. And to agree for giving this very important Vikram Sarabhai lecture, friends and colleagues, let us welcome Dr. S. Somanath with a round of applause. Sir, Vikram Sarabhai Memorial Lecture is one of the prestigious lecture. Every year it is organized by Indian Society of Remote Sensing in all the national conventions. And friends, it's basically my humble duty to introduce to you today's speaker, Shri Sridhara Panikkar Somanath ji. Anyway, Dr. S. Somanath's name is now a household name in India. Everyone is, knows him very well. However, for the sake of, our young friends and all, I would like to read his brief biography. Shri S. Somanath ji is Secretary of Department of Space, Chairman, Space Commission since January 14th, 2022. He is known for his significant contributions in system engineering of launch vehicles, PSLV, GSLV Mark III. He obtained his BTech in Mechanical Engineering from TKM College of Engineering, Kollam in Kerala, and Masters of Aeronautics Engineering from Indian Institute of Science from Bangalore, specializing in structure dynamics and control with a gold medal. He is recipient of Space Gold Medal from Astronautical Society of India, Merit Awardee and Performance Excellence Awardee from Indian Space Research Organization, and Team Excellence Award for GSLV Mark III development. The Indian Society of Remote Sensing, ISRS, has conferred Bhaskara Award on him in the year 2022 for his outstanding contributions to overall growth of space science and technology and its applications in the country. Shri Somanath ji joined VSSC in 1985 and was the team leader of integration of PSLV during its early phase. As director of VSSC, Shri Somanath ji assumed office in January 2018, and under his able leadership, VSSC has achieved significant milestones like crew escapes system demonstration through pad abort test and launch of GSLV Mark III for Chandrayaan-2 mission. Under his able leadership as Chairman ISRO and Secretary Department of Space, large amount of space science, space exploration, and human space flight related activities are being carried out. And the most significant and important milestone, which all of us has witnessed, was the successful landing of lunar, landing module on the surface of Moon in Chandrayaan-3 mission. Subsequently, Aditya L1 and Gaganyaan technology development missions have also been accomplished under his able leadership. Shri Somanath ji tirelessly contributes towards the space technology and its applications for the development of the nation, as has been demonstrated by successful launch of other, ISRO's Earth observation satellites, including EOS-6 and EOS-7. He is leading ISRO and providing, various impetus and, support in terms of, role of geospatial technology for national development and Earth observation systems. Currently, we are under his able leadership, we are defining and the next set of Earth observation satellite systems, which will be very useful for the development journey of our great nation. With these words, I welcome you, sir, once again to deliver this 32nd Vikram Sarabhai Memorial Lecture on the topic of space exploration, the approach and vision in the Amrit Kal. Over to you, sir.
Thank you, Dr. Prakash. I hope I am audible there. Somebody may please confirm.
Yeah, yes, sir. You are audible.
Yes, sir.
Okay. Now you can uplink the PowerPoint presentation. I hope the presentation is visible there.
Yes, sir.
Okay. So thank you so much, ISRS and ISG, for inviting me to give this talk in memory of Vikram Sarabhai. This is a 32nd memorial lecture. I'm really honored to be amongst many other great leaders who have delivered this lecture before. And this year, specifically, I have an honor to deliver this, though I am unable to be physically present there for the symposium. So my regrets for that. I hope that the online way of talking today has become a very standard way. So I thought this is okay when I am at a difficulty of traveling and then being with you during this important seminar symposium. The themes that you have set for Geo Discover, the Unraveling India's Spatial Frontier, Inspiring Geospatial Ecosystem Trends and Innovation, it's all are very, very appropriate. And I believe that the work which we do in this domain is really going to be very phenomenal. Let me take the leadership of ISRS for organizing this such symposium, bringing all the stakeholders to discuss this topic. There are some presentation elements related to this, though my topic of presentation is more into exploration, etc. But then the initial part, I would like to do a little bit on the roles of the GIS and other related observational capability on our governance and economy. Start with the next slide, please. Can you just move those? Yeah, those type of, yes. Just move it. Okay, just I want to start with telling the space technology and applications in service of humanity is something very, very important. I think now the observational capability from space, which gives you a very fantastic opportunity to look at various SDGs, which are very important element in terms of natural resources planning, climate impact, renewable energy, disaster mitigation. In these areas, geospatial governance, sustainable development. So really the socio-economic security angle, if you look at many of the capability in spacecraft, observational capability, it really helps you. Please work on it to minimize. There are many things. Yeah, just go to the more. Okay, next slide. The geospatial governance is very important because as far as ISRO is concerned, we have been working with departments and ministries for various domains of applications of remote sensing and various other PNT services, communication, etc., for various applications. And the government was very forthcoming in making it institutionalized through various projects, programs for public good. And this has been the way we have been handling this in the past. Various elements like agriculture, irrigation, watershed development, the urban citizen-friendly cities for that information providing. Otherwise, simply the public benefit schemes, how to make service delivery better, decentralized governance, rural connectivity, disaster management support. Like that, many large number of projects department has been handling with the support of the ministries. And this has been the way we handle this, the whole of the capability that existed in our spacecraft. But we are now changing the model a little bit, which we'll describe later. Next. Gati Shakti is very important element in the current government's approach to using space-based data, in which the satellite-based data has become an integral part of the Gati Shakti program. And availability of the data for supporting this is very, very important. For example, the Earth observation missions that we have, the data policies that we have today, and continuity of various data by making newer satellites and deploying them as soon as the previous satellites become non-functional or defunct or life is over. So this is a very important aspect of our building capacity to handle providing enough data to the users. Similarly, there are new things emerging, especially the startups, the ability of them to come up with more data and corresponding applications in the market by the private is also something which is emerging, which possibly definitely will add up to the capacity that we have already in this sector. Next. We know that the changes that is happening now in the EO data processing and dissemination, probably the whole of this is changing in a manner that it's no longer the data that's important. It is the decision-making capability based on the data. So that analytics becomes very important, and decisions finally out of it becomes important. So the huge amount of data processing, and then understanding physically by people and then take decisions are now shrinking. And the satellites are becoming more intelligent, especially with AI and edge computing available on board, the data that need to be downloaded, and the type of decision-making support that are available is actually changing significantly. So these aspects are that what I have tried to do this, which is a combination of various things, like the data collection, processing, the AI engine, the network of communication, the geospatial network that we have, the revisit capabilities, and various observations happening in multiple spectra becomes very important. And today that we look at a large amount of capacity development need that has been identified. Next. In the emerging space applications, as I said, it's a similar thing that I want to tell you, that the satellite internet, which is something which is now becoming very, very important, and IoT becomes important. So these two also becomes an integral part of the whole of the ecosystem. It's not just the data comes from the observational capability, but communication gets connected to it. Even timing, location service also become connected to it. So that becomes the new emerging way of creating new applications. Next. Similarly, it's no longer the satellite alone. So we get data from various other sources. It could be the cameras on board, the ground, or it could be the drones and various, even mobile applications will help you to really collect enough of data. So this becomes processable at various levels. For example, in terms of agriculture, I have the opportunity to see some of the startups and companies demonstrating such capability, not based on satellite data alone, just mobile data, how they are able to help make decisions based on various other models that exist. So this is something revolutionary today. Even sensors that are deployed in agricultural fields, how this data is collected by satellites or even mobile networks to transfer it to some compute stations and then make delivery of decision making. Again, the decision making is also automatic, which helps the farmers to bring better yield and outcome out of the whole of these networks. Next. In industrial ecosystem also, this becomes very important. The communication, EO, the position, navigation, and timing services become an integral. For example, the concept of smart city is actually based on this. Of course, we need a lot of observational capability to create the base layer. On top of that, the change detection and its impact assessment. Similarly, the PNT becomes an integral part of the entire fleet monitoring, manufacturing, IoT, etc. The communication infrastructure, irrespective of which field that they are coming. Similarly, traffic management is another example by which that you can look at the whole of the observational network as well as communication network and PNT services become fused to create the future. I think all of these are happening now slowly, but not to an extent that we wanted it to be currently. But I am sure in a few years from now, this becomes the norm in which the many of these services become agnostic to the type of platforms that we have. There will be the distinction between EO, the communication, and PNT services, even in satellite building itself, is going to vanish in the coming days. Next. Now come to the economy, which is very important. As far as the application side of economy is looked at, we see the whole of this application side of economy or space is very, very rewarding to invest. This is something which I would like to tell you. Very important thing is that the risk of failure is actually minimum, technology complexity is minimum, and the share of the economical and risk as well as the return of investment in this is actually very high. So we would like to see in the long term, more and more people investing in space-based applications where the GIS as an important element. There are many other aspects as well. Communication is also important, television broadcasting important, ground equipment is important. But then if you really invest in application side, it will actually create more opportunity in the upstream side, basically the satellite building and launches. So this is something that we would like to do through the regulatory mechanism in space as well as enabling mechanism in space. And for that, there are new programs and projects which we are currently working on along with InSpace to make sure it is deployed in the coming days. And I'm also happy to note that new startups and companies have come up in this domain, which they are successful by their name itself. I think many more need to come. I think the market is still very nascent stage, and it is important for looking at how new applications can be envisioned by these companies. And I'm really able to see that is happening now, and young people are able to identify where the potential of the market is with the same data sets, but add more intelligence and processing into it to make decision making, and also the usability much more better than earlier just data alone. Next. In overall sense, in the economy of space, the whole of this element of application, especially the second order impact, is very important. For example, satellite data industry, it's going to play a very important role in our overall scaling up of the space economy. For example, the broadband services, non-satellite industries are the one which is going to detect the overall scale of activity. Of course, the other domains are important, like manufacturing, satellite building and launches. So all of these are important. So we look at the overall context of space economy expansion coming days in the Amrit Kal. If it has to really scale up to the level that I have just depicted, community, basically to provide unhindered access to space technology and do every domain of work in space by the industries. So I invite now, this is an opportunity for everybody to look at space application as a dominant area where we have a potential to invest and then reap the benefits. Next. I also want to tell you 2-3 slides on the NavIC, which we started many years back. The NavIC base layer is currently operational, but then there is something critical for it today. We have a civilian and a strategic sector here. The civilian is currently operating with 2 bands called L5 and S band, whereas the strategic sector also operates with this band. So we wanted the civilian sector also to grow. So the induction of L1 band into this becomes important. And similarly, the base layer creation of 7 satellites currently is still not there. So we have in the process of building additional 4 more satellites. One of the 5 satellites approved is already launched. The remaining 4 also will be launched to make the L1 band fully accessible for standard mobile users without, like GPS. So this is one goal. But I want to tell you that our NavIC has fantastic capability in terms of better accuracy and reliability compared to that other services that are offered across India. So this is a regional specific constellation, and also with a geostationary satellite. So it naturally gives you a better precision as far as the location service is concerned. So we hope that over the next 1 or 2 years, we will have the full constellation, and adoption of this into our entire life of the whole services will become natural. And equally important is the strategy sector, which is separately an issue which we are discussing with all the users. And one of the goals that we have is that it's not just limited to this regional domain. We want to extend it further. We are looking at how this can become a little more than the regional by creating a more like a MEO-GEO combination. So additional set of satellite launching so that it extends wider into the European and the Southeast Asian domain. So we have a larger fleet control, for example, ships traffic, which will be better equipped. Aircraft traffic will be better equipped with this type of support system. So it's a combination of GEO and MEO, which will give you a very good freedom operation, high accuracy, and better access for civilian as well as strategic users. Next. We already have certain amount of civilian use in NavIC, but this is not very high penetration into the mobile phones. Though there are 24 mobile phones currently where NavIC chipsets are available, but it's still not operational large numbers, primarily because of the L1 band not being incorporated, other than L1 band not being incorporated by adding additional chipsets. So once L1 band comes, you don't need additional chipsets. It's simply the software, hardcore coding is enough, which will enable this to happen. But we have already installed NavIC in various other services like the train and other fishermen survey, coastal security, etc., which is a civilian application. But these are based on ground-based equipments, which are a little more bulkier than mobile phones. But we hope that this will change in the coming days. Next. Now, let me go to my primary theme of the talk, which is vision in Amrit Kals for space. When this was discussed, our Honorable Prime Minister was very excited to discuss this topic, and he reviewed it specifically. And this is his vision that I just wanted to put in one slide, but more details I will explain. What he said that we must have a Bharati Antarisha station by 2035, which is fully functional, where human beings can go and start do experiments. He also suggested that we must have a human space flight program as well as a moon exploration program by which an Indian landing on the moon should be achieved by 2040. This is a very important dream that we have. To meet it, we need to do following things. We have to develop newer launcher capability. We have to create newer launch pads to handle such complex missions. We also develop human-centric laboratories and associated technologies and continue our exploration to Moon, Venus, Mars, and other planetary objects, primarily to create the capacity to look at further scientific exploration. So this is the overall sense, the whole program. But it looks very simple in a slide, but that the content of this work is huge. I will explain a little bit later. And also some additional elements of our vision in the Amritkala as well. Next. So we worked internally in the recent times and created a vision line. This is through our Chintan by Shiver, which we happened in ISRO and other agencies like the NSIL in space and other stakeholders, Department of Space. And we found that there are 3 tracks. One of them is a Chandrayaan track, where we have landed safely with the Chandrayaan-3 soft landing. But to do future Chandrayaan missions, we need to have capacity like the docking capability. We must be able to bring in samples from there. We must also do long duration moon mission, where the last mission was just 2 weeks. We couldn't do more because of the various other limitations. This must be overcome, and we should do long duration missions. We must also create habitable capability there, and also building stations at the moon over a long period of time. Next track is called the exploration track, where we create capacity to orbit Earth, human access to space through Gaganyaan, building space stations, cislunar possibilities, and human landing on the moon. So this becomes another track. The very important track is the launcher capability. Unless we have this capacity, none of these visions are possible. So with the limited capacity of launching today, we see that it cannot grow beyond a point. We need to develop newer rockets, high capacities, so that we can achieve all these dreams over a period of time. And we have envisioned how the future rocket should look like in terms of its mass, payload capacity, cost, production capacity, friendless, etc. So finally, after all of this, we will have a sustained moon-based economy, which will work on various models. Of course, it includes tourism, planetary exploration, science, base for future exploration, etc. So this is something that we need to achieve over long periods of time by continuously working on technologies and capacity enhancement in industries. Next. Why I say all of this is, why this fora is important is something which I would like to tell you. All these technologies that we develop for this, whatever I shown earlier, actually fits to the application side a little later. The Gaganyaan program currently we have is looking at achieving in 2025 if everything goes well. We have an astronaut pool today. We have also identified technologies which will ultimately lead to the Bharatiya space station. And currently we work with so many agencies in India and across to create this capacity. But then for the future, we need to do much more, like the new rocket and the space station building. Why I talk about all of this is that because the space station is so crucial. When we have the human space capability, we also create a possibility to do scientific research in zero gravity environment. And all of you know that the future scientific research has to happen there, specifically in terms of material sciences, the medical applications, including organ building, research in future drug discovery, plant science, etc. So this becomes very important, and we would like to see this as an economic activity rather than just a fanciful thing. This is a goal. Next. So the detail of the Bharatiya station is still under construction. The crew module where we will travel will have a docking capability, and we will have a robotic capability to connect to this crew module. And this is something which we would like to do unmanned to start with, and then it will become manned in the future. We would like to see a first module of this to be launched by our existing launch vehicles by 2028, and future modules by our newer rocket, and build up full station by 2035. So the initial scaling of this space station is currently we have a separate committee who is going to look at it, and we target something like 25 ton will be the mass to start with. Possibly it may grow in the future. Next. Another domain is space science. I think all of you are aware that we have planning missions to Venus and missions to study upper atmosphere. And our work on various other missions like the Mars Orbiter mission, the Chandrayaan-1 to Chandrayaan-3, the AstroSat has yielded huge benefits in the scientific community. We created a lot of pool of talent to understand this data, analyze this data, and create new knowledge. So the primary role of scientific mission is to create certain technology capability which will feed into other operational missions in the long term, and also create the type of talent pool across institutions which will sustain it, so that new instruments will be built, new algorithms will be built, and new possibilities of using the high capacity to land, the moon, etc., will be utilized by this community effectively for future business and commercial applications. So we would like to look at science just not for science alone. Science is important, but most important is a capacity building as far as this is concerned. I will go to some of the future scientific missions next few slides. Next. Aditya L1, all of you are aware, the solar science mission is something is on its way to the reaching the L1 point. This is specifically targeted to study the sun with the help of other institutions. I would like to tell you this is primarily with the support of other institutions like the IAA and the IUCA that we have built the instruments on it. Of course, ISRO's instruments are also there, specifically looking at the solar coronal mass ejection and its secondary effects through very planned measurements in various aspects like the coronagraph, the ultraviolet, the observations, the X-rays, the low energy and high energy X-rays, the plasma, and also the magnetic aspect of the region between Earth and Sun will be measured. And this will be correlated with the CMEs, the coronal mass ejection processes, to understand the whole mechanism over long observations, unhindered observations from L1. Next. And we are getting ready for launch of XPOSat, the X-ray polarimeter satellite, which is very interesting satellite, again built by another laboratory called the Raman Research Institute, along with ISRO people. And we have other measurement capability in addition to this on board the satellite. The satellite will be launched in the next PSLV launch. And this will give better understanding of the emission mechanism of the black holes. And we are currently working on yet another satellite called SpaceX, which is going to demonstrate the docking capability of satellites. So 2 satellites will be launched in the integral mode, and they will separate in space, travel over kilometers, and then come back and join together to demonstrate the automatic docking capability. Currently, we have tested all of this in laboratory in a floating environment, but then real testing in space is something very important for us to demonstrate and scale up for future missions that we just now discussed. Next. The scientific mission currently under discussion are the Disha, which is a dual satellites which will look at the aeronomy and characterization of thermophysical and ionospheric response to space weather. As I said, the CME is one of the elements of the space weather. Similarly, this is also complement the Aditya L1 observations. Here, the scientific intent is currently under discussion. The Venus mission has reached a reasonable level of maturity in terms of definition of scientific goals to study Venus, its topography, atmosphere, etc. And Mars, we have already gone once, but getting into the atmosphere of Mars and then the land on the Mars and do a detailed in situ observation on Mars is a goal that we have set for ourselves. And this will be worked out in the coming days to understand Mars better. Possibly a rover, copter, etc. can be included in such a mission. Of course, this is currently under discussion in terms of scientific objectives. Next. We are working on a ISRO JAXA joint venture mission to land on Moon. The rover will be built by JAXA, the lander by ISRO, and the launching by their rocket H3. And the whole purpose is to bring the drilled samples back to for study by ISRO and JAXA teams. We also work on next astronomy missions. This currently is under discussion. The INSIST, the DAXA, they are currently under conceptualization level. Of course, detailed engineering has to happen. And also we have to develop the user community and science community who will make use of this data. Currently, they are very, very small community. We also look at exosolar planets to look at how they becomes observable through some of the satellites, some of the telescopes that we put in this satellite, and then characterize its atmosphere for potential living conditions. Like when the atmosphere is observed through the light from the star, that we'll be able to do a spectroscopy and then make the understanding. But doing all of the science missions, we have great challenges in terms of the ability of detectors and manufacturing such electronic components in India, which is very crucial, which we would like to solve in the coming days. Next. The sample return from moon currently is in conceptualization stage. We call it Chandrayaan-4. Here the goal is to bring back the sample from moon using available technology today with us and available rockets with us. So this is the current planning. We already have capacity to bring samples back from atmosphere, the orbit of Earth back to Earth's surface. And we are demonstrated by the CARE, the SRE module experiments. But complemented by docking capability, we will be in a position to bring sample from moon to Earth's orbit, transfer it to an Earth-based capsule, and then bring it back to the Earth by parachute systems and deorbiting. And this is a goal by which we will be able to bring back the sample with the capacity for the current launchers. But of course, the detailed mission study review process just started, and it will be very exciting mission to look for. Possibly by 2026, we would like to achieve, and this one going to be one of the earliest scientific mission that is going to happen now, other than whatever is already scheduled. Next. And one of the important thing which we would like to work on is the artificial intelligence and machine learning in space in big manner. We already started in rockets. We also have to have spacecrafts to handling this autonomously more and more. We would like to have space traffic management. You know that a large number of satellites are there. Observing them, controlling them to avoid collisions is very important, very critical. Today it's done based on ground-based observations. What can we do it with the space-based activity where spacecraft will be automatically able to do them? Creating humanoid robots are important. Robotic capability is important. Digital twins are important, and analytical data analytics is important. Now, while we do target all of this, AI is currently being used for various applications now. For example, we look at it AI as a fault diagnostics and prognosis processes in defect identification. We also use in intelligence in vehicle health monitoring for human spaceflight capacity. So AI and ML in various, even GIS, I know all of you know that, I don't want to stress on that, how AI-based engines are going to be very important for object identification, classification activities, and also the image transfer reduction, volume reduction in downloading images from space to ground can be substantially reduced if we are able to do a little bit of computing on board and bring down the data volume. That means the constellations can become very efficient. The ground stations requirement also can be better, and downline processing time can be brought down substantially. So all these are important in the coming days. Next. Of course, I talked about the docking capacity. We also work on robotics, basically to look at how tethered robots for satellite refueling, capturing, and bringing back is very important. And our satellite center has already made prototypes for an ISRO servicer mission, where we'll be able to go and service a different satellite, either transfer fuel to it or make it deorbit. I think these are objectives that we have set for ourselves in the coming days to be achieved. Next. In the satellite side, there are many technologies that are going to be developed in the coming days. In the communication side, the primary objective is to increase the throughput, because many a times the streaming videos becomes a requirement today from space now. I think already some people have already built such capability. For that, we need optical and quantum capacity. For optical communication become an integral element of such a thing, and quantum becomes important for communication network security. In the observation side, we need more intelligence of the imaging capacity. For example, hyperspectral and SAR, PAN, and MEMX fusion becomes very important. Hyperspectral, I can tell you, it's going to be very, very important for much better identification of materials and data out of than what is available through other modes of observations, other methods of observation. And similarly, the PNT services, where navigation we would like to look at, as I already mentioned, the larger expanded coverage becomes very important. And science missions, we look at the points which I already mentioned. So in satellite building, we have various domains which we want to work in the coming 20 years or so on all of this capacity development. Next. As I mentioned, the debris monitoring and situational awareness in space is very, very important. We have created a laboratory called the IS for Home, where we have created mathematical capacity, observational capability, prediction capability in various areas, in collisions that can happen in space, satellite data that are available from public domain, analysis, and then advisories for various people, and create basic R&D capacity in space debris monitoring and near Earth objects monitoring. So this is currently created, but what we do not have is observational capability. So this is something that we would like to look at in the coming days. Next. So currently we have a large multi-object tracking radar at Sriharikota, but then we are looking at how to create more and more radars. And we did a study, we found that at least additional 6 radars and large number of optical telescopes are distributed across the country are needed for large coverage of observable satellites from India, because this is very important for security of satellites and our assets to be secured. So we create this capability over a period of time. And based on technology available in Indian industries, we would like to build these additional radars, which will go up to, so say, 2,000 kilometer range for at least 10 to 20 centimeter in resolution. So this is a very important goal that we have set for ourselves and working on new project called Netra. Next. And we also have strategic need. Equally important is to have observations across India. This again, though the GIS comes in big manner, and various observation over in and around the Indian borders and the ocean area becomes important for us. So we are looking at how to build newer satellites to handle this capacity. Next. So some of the capacity that we are looking at in this is to have high revisit, typically 2 hours revisit under all weather conditions, and data fusion analysis capacity, almost near real-time dissemination of the data. So we look at high resolution of all the critical zones and maritime observations across the sea, and also very high resolution satellites of various nature, radar satellites, and also a high resolution continuous observation from geospatial object called AGI-SAT. So we have various type of satellites right now currently being configured for building in the next 5 years. So this is one of the goals. Next. So one example is the AGI-SAT, where we would like to around 15-meter resolution and create videos as well as the full subcontinent view, or also spot beams, spot locations wherever we need a high resolution. So it's a fixed satellite that will look at the Indian continent, subcontinent for continuous observations, which will become very, very important for a general view, and we can take high resolution images using other satellites wherever their criticality. It will be very useful for like disasters, security, etc. Next. We also want to look at how to build capacity in automatic dependent surveillance, especially the aircrafts that fly here, and how our constellation of satellites can detect ships, aircrafts, and other objects that are around the country. So we look at this capacity. We demonstrated using some payloads in the recent times, and we were able to detect aircrafts significantly in numbers very accurately, and we did a prediction that what type of constellation, if you deploy, the whole area can be covered with a very low cost constellation. Is currently under discussion with the various stakeholders. Again, very important is the communication. Communication for strategic users is important. For commercial users, of course, all of you know the DTH and other services, internet services are handled more commercially. But more importantly is non-commercial services, which are specific services for users, is also one of the work that we do in ISRO. Next. So the last, I would like to tell you, the moon landing by 2040, if it has to be achieved, we need to cover a lot of grounds. In terms of the launcher capacity and enhancement, the capacity to build Gaganyaan capacity in numbers and launch space station modules. Chandrayaan series of satellite. The Chandrayaan series is just a name that I have given, but all of them will not be like this. But it's a series of satellites which will upgrade its capacity of various kinds, moving away from the current landing to return, more of robotics and more long duration missions and in situ resource utilization capacity over a period of time, and going along with that, the other exploration capacity in, to other planets and bodies. So while we do all of this, finally we will end up with that capacity to handle Indian moon mission as landing on the moon, so that finally that glory can definitely come to India. I'm very sure about it. Next. So with this, let me conclude my talk and say that I have given a very general view of what we have in store for next 25 years in space sector, starting with the GIS capacity that we have already built and deployed. And we also have other ministerial satellites which are going to build, and department satellites which are going to build in the civilian sector, and that they are there and will be done in the coming 5 to 6 years of time. and we have already started the process of user aggregation from various ministries and departments. Equally important is also an initiative by InSpace to bring private companies to build space observational capacity for commercial data utilization. This is going to be incentivized by government to build more and more satellites, small satellites with a high revisited and high resolution capacity in the optical as well as near infrared and hyperspectral capacity. Hopefully, this call for incentivized launch of such constellation by private industry will be taken up, and which will definitely bring data availability not as an issue in the whole of the sector. So thank you so much for this opportunity given to me to deliver this talk today in the ISRS symposium. It's a great honor for me to showcase what the Honorable Prime Minister has envisioned us, and we are working on the journey of space program in the next 25 years on these lines of vision. And it's becoming more inspiring to each one of us to work on such possibilities which are never ever been detailed by anybody else other than our Honorable Prime Minister. So this is something which we look forward in all ISRO centers to work. And I am sure the technology elements that we get into this activity will help in many sectors, including the capacity for observational capability that we need to have in the coming days. So thank you so much for this opportunity once again.
Thank you. Thank you very much, sir, for giving a very comprehensive presentation on the approach and the vision for the long-term space program of the country, as has been envisioned by our Honorable Prime Minister. You have touched upon, the various developmental requirements in terms of achieving these very fascinating goals by putting humans onto the moon surface by 2040 and having our own space station, follow on lunar exploration, as well as planetary exploration and Earth observation mission. So I am sure that the audience which is there in this hall, which comprises of academicians, researchers, and young students, have got thoroughly benefited from your very comprehensive talk. Sir, we still have few minutes left, and I request you to take kindly one or two questions with your permission. If you agree, we have a lot.
Please go ahead.
Yeah, we have Dr. Shailesh Nayak with us. He is former Secretary, Ministry of Earth Sciences, and he was the chief guest of our today's inaugural program. I would like to request you, Dr. Nayak, to steer this Q&A session. Thank you very much, sir.
Thank you, Prakash, and thank you, Somanath, for very inspiring talk. Actually, to have a vision is one thing, but to make a plan to implement that vision is a very challenging task, and you did extremely well. We open the floor. Is there any questions? Please raise your hands. I think mic will be provided to you. Yeah, please.
You can introduce yourself briefly, tell your name and your question. Maybe, yeah.
Good morning, sir. It's a pleasure listening to you, and it's a dream come true to listen to your lecture here. I'm Dr. Karthik Nagarajan from Pillai HSC College of Engineering and Technology. I'm here with my principal, Dr. J.W. Bakal. So for a kind information, from 2017, we have started capacity building program in the field of outreach center, and 18,000 plus students have studied from our institute in the capacity building. Now, looking at the space science in the coming future, a lot of missions are going to come. Can you just give a line of sight or in the approach which academicians like us, a college like institute like us, where actually we are in the middle of a rural area in Maharashtra. So can you help us or guide us how capacity building can improve in these rural areas, considering the coming future missions? Thank you, sir.
Currently, the capacity building initiatives are spearheaded by various institutions in ISRO, like the NRSC, which does a lot of outreach for that, the IIRS, which does the training program. And we also have the other modes of capacity building with the student community, etc. But I tell you, the capacity building involves various elements of it. For example, in terms of general understanding of the space and opportunities available in space is one aspect. But then developing capabilities in sectors is important. And equally important is applications delivery for needy people. So I will put all of them in various baskets of type of capacity that we need to develop. Of course, training becomes an essential part of it, and people awareness becomes important part of it. For example, if an institution like you are able to bring people from the rural area, like the panchayat heads or the users who understand this, give them as a sort of an exposure to the type of applications that are useful for them, it will be very beneficial for them. See, this is very important. Many people are still not able to access space technology or its GIS based decision making tools in their day-to-day life. This is a very big gap. And it's okay, we technologists and scientists talk about great deal, but then the ground realities are not that encouraging. I think I would like to tell you this. Of course, we have done a lot of work, but still it has not reached the real needy. So where can you play that role, and how that role can become both rewarding for the institution like yours and also an activity that can become an economic activity. These are the ways to look at it. If you look at it as simply a service, a free service, it will not work very well. So can you develop a company within your institution who will do this work on a commercial manner? It will definitely help the company. It will also help the panchayats. So if it brings benefit to the panchayats or village administration in terms of better planning capacity, they will pay for it. There is no worry about it. This is one aspect which I want to tell you. Second is student community who will like to get into space sector, how to build their capacity. So here there is a way to do custom designed courses for them. This we have specific courses available. Of course, Dr. Prakash will be the right person you can consult. I don't have to advise. So you can have a discussion with him to help you plan such a thing, how to do it for students in the institution. I think you may be already aware of it, which is now the third element of your question is in the future plan, how you can get engaged. Now here, there is a lot of opportunity. My offer is in terms of science aspect of it. See, if you have an institute where you can potentially use this data coming from science missions and derive scientific outcome out of it, it will be fantastic. In India, we are looking around for people pool who will be able to use the science data. For example, Chandrayaan 1, 2, or even other missions like AstroSat, there is certain amount of scientific pool, but still there is a lot of people from outside the country make use of it. How to develop that capacity in India for them to scientifically analyze this data and then bring out publications and research. This is very important. So, and again, the last point is instrument building. Here we still lack, and some of the laboratories who today capable of building high quality instruments are very, very less. So if you can work, and here it requires physics of the problem, you should be able to understand. You have to integrate with the sensors, the electronics, and then finally delivery of the scientific data. For example, you look the XPOSat, the X-ray polarimeter satellite. The polarimeter of X-ray is a very unique way of how to look at it. You should see the instrument. Similarly, the instrument on board Aditya L1, the solar coronagraph, a fantastic optical instrument, fully conceived and built by our scientists. So these are type of potential opportunities in all these missions. So look at all of them. I think if you can find out a joint department program, we will build some instrument for our scientific mission. Decide that and start thinking about it. You will be able to achieve that goal in 1 or 2 years. Thank you.
Thank you. We'll have one more question. Yeah, please. Can you?
Sir,
Yeah, okay, please. I will come back.
My name is Narayan Paningrahi. I am from Center of AI and Robotics, Bengaluru. So my question is, any plan for developing a quantum sensing, replacing the conventional sensing from the satellite? So quantum sensing and any plan of predicting a prior earth tremors or some of the disasters which is going on?
Okay, the current work in ISRO is in the quantum communication. We have successfully done that today in both the methods of quantum, the quantum entanglement and single photon devices has been successfully accomplished by our SAC along with the Raman Research Institute as well, and PRL, of course. And we have already developed a payload for quantum key distribution capacity through space. So this is primarily targeted for only encryption on security of communication networks. Currently, we have not developed a quantum sensing capability within ISRO. We have currently nobody working really. So we'll be happy if you are able to find somebody who is working in this. We will be happy to associate and look at it. For example, the earthquake. Earthquake is still a very enigma for anybody in this domain to predict from space. Of course, from ground, of course, there are some instruments looked at, but even there, the time availability and other characteristics are very limited. So if you can find out some solutions to it, it will be fantastic. So if you find there are the right type of contacts, we'll be happy to contact them and then work.
Thank you. Yeah, please.
Sir, my name is Shri. I was with United Nations Office for Outer Space Affairs and also led UN Spider program globally. And I have observed very closely how space program was developed in China, Europe, and United States, and also involved in current space. So my question is on space policy, this thing. So upstream segment we are trying to strengthen, but downstream segment, the biggest consumer is always the government still. And when I'm trying to convince NDMA or agriculture department that you should own this so that upstream segment can really develop technology for you and they will be able to raise the capital for their development. But this is not really working well, and this is really alarming me whether we can really sustain upstream economy and downstream together. If just a small example, 150 crore was spent by government of Maharashtra to buy one-time satellite images just 6 months back. If that was invested with the startup to develop satellite for Maharashtra government, would have taken much more stride in developing the satellites and getting continuous data availability. How to pass on this message? Individual like me cannot do it very well, but I hope with your help, this message can go very well to the departments. That's my question.
Thank you. Your view is very important, correct observation. But I would like to tell you, this is something that we want to change. First, the government becomes the largest consumer of the data is a wrong thing. See, and depending on government to become the consumer and planning for the entire Earth observation fleet is not right, in my opinion. So we will, if you are really looking at it as a business opportunity, it is bound to fail if you in that model. So what is right is the real consumer of the data should come up. For example, an agriculturist, the farmer, if really he is able to access this product, the support from the data on a real-time basis at an affordable cost, like your mobile phones. Say, he will be happy to pay a certain amount of rupee for his benefit of advisory. So other than government taking data and providing us free services, it will not sustain longer. Government is not supposed to do this. Governments are enablers. Government is not the doer. So this is something that is slowly creeping into the understanding of it. So government generate policy, government creates a support system, but government doesn't do. So the whole issue of buying 150 crore worth of images by the government happens on account of this policy, which is something is to be corrected in the basic root of the issue. Then the point you mentioned about the buying of the satellite data from somebody and doing a satellite for Maharashtra itself also has its own challenges, because with 150 crore, you won't be able to put a good satellite which will give you any good images. Of course, you can put a satellite if you want, but that will continue to provide you with the revisit and other capacity, which is not, which will not be meeting that objective of doing it. It requires few thousand crores if you want to really put a good set of satellites, which will give you the images they purchased for 150 crores. So it's not an equivalence, it doesn't exist. So I would like to tell you that it's important that we create private ecosystem to deploy this satellite. I just mentioned InSpace is trying to do this by creating a private satellite observational platform owned by private on a commercial basis, and they will be able to deliver it. If they are able to deliver it, we will incentivize it so that that becomes a data source for all nations, all users, and on that applications can be developed and deployed. Actually, there is no need to buy data. I think this is another major issue. We must find way by which we are able to take decisions rather than just data. I think many things are associated within policy. Data per se, geospatial policy currently has become very attractive. It allows you to give you a certain amount of data at low cost, which is available through private investment. Public funding, which is already there, which is very good thing to happen, including high resolution data. So it's really good thing to happen. Possibly with the better satellite, ISRO is going to put the dependency on buying data has to come down. Thank you.
Thank you, Dr. Somnath, for this interaction. Thank you very much. Thank you.
Thank you very much, sir, for sparing valuable time. Now, as we are coming to the close of this particular session of Vikram Sarabhai Memorial Lecture, I would like to request Scientific Secretary ISRO, Shri Shantanu Bhattapedekar and Director EDPO to do felicitation of our Honorable Chairman, ISRO and Secretary Department of Space on behalf of Indian Society of Remote Sensing. Shantanu ji. Dr. Thomas and one of our directors from Symbiosis Institute is also there. So maybe both of you can join in honoring the chairman ISRO. It's a small honorarium, sir, for this lecture. And once again, I would like to thank you for sparing your valuable time and engaging with the audience here at ISG-ISRS Annual Convention and delivering this 32nd Memorial, Vikram Sarabhai Memorial Lecture. Thank you very much, sir.
Thank you.
With this, we conclude this ceremony. Thank you. Thank you for joining, sir. We can disconnect now, sir.